থেকে পারসেপট্রন থেকে শুরু করে আফটার দ্যাট তোমার যে অ্যালগরিদমস আছে, লজিস্টিক রিগ্রেশন, লিনিয়ার রিগ্রেশন, এসভিএম, তা পিসিএ, এই নানা রকম যে জিনিসগুলো আছে সেগুলোর ম্যাথামেটিক্যাল অ্যানালাইসিস পড়ানোর পর তারপরে তো কনভলিউশনাল নিউরাল নেটওয়ার্ক। তোমার এআই সাবজেক্টে কিছু নেই।
ওকে 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 স্যার।
স্যার হ্যালো স্যার,
হ্যাঁ বলো।
বলছি স্যার প্রোলগটা কি আমাদের আছে সিলেবাসে? তো দেখলাম গো থ্রু করলাম, নেই তো স্যার কোনো জায়গায় লেখা।
প্রলগ নেই?
না স্যার আমাদের তো নেই প্রোলগ, প্রোলগ বলে কিছু লেখাই নেই।
আচ্ছা
ওই জন্য আগের দিনও স্যার দেখেছিলাম স্যার,
আচ্ছা, যাই
ওই
হোক,
জন্যই স্যার।
ওই মাথায় ঢুকেছে যতটুকু অতটুকু ঢুকিয়ে রাখো। 7 সেমে যেমন প্রলগ আছে, তোমাদের যদি না থাকে কোশ্চেন দিলে যেন অন্তত নামটা বলতে পারো, ব্যাস তাহলেই হবে।
হ্যাঁ স্যার হ্যাঁ।
সো দ্য থিং ইজ দ্যাট, যে আমরা যেটা পড়েছিলাম, দ্যাট knowledge representation system, that means how the knowledge is structured in a program. So there are standard set of knowledge representation technique, any of which can be used alone or in conjunction with other to build an expert system. That means there are some knowledge representation technique. First is that is called rule based technique, that is a rule based technique. Second is semantic net, semantic nets based technique, and the third one is frame based technique, frame based technique. So we know in case of rule based technique, that is rule based technique, in case of rule based technique, in a rule based expert system, the domain knowledge is represented as a set of rules. Here the domain knowledge is represented as a set of rules that are checked against a collection of facts, that are checked against a collection of facts or knowledge about the current situations, or knowledge about the current situation. So we know that when the if portions of the rule is satisfied by the facts, the action specified in the then portions is executed. So like that, it may be possible that how you can design a rule based technique, say a robot that visits a zoo. So it notices animals having, you can say, certain characteristics, and it is unable to identify the animals. A robot is unable to identify the animals, so it needs the help of a rule based expert system to identify. That is called identifier. So we can say, we can I am just designing a rule based system to just give you the understanding that how this expert system can be built. That assume there are 7 animals, assume we can say that there are 7 animals. So it may be 7 animals like that: cheetah, tiger, giraffe, zebra, ostrich, say penguin, and
Rhino.
albatross. So the thing is that how we can design the expert system. I am just writing some rules. It should be like that. If we writing the program like that, rule 1, and there is a if statement, say the animal has here, the animal, then the result is it is a mammal. Say we have to design such set of rules to define the particular animals. So we can say that, and rule 2, say I'm not writing all the
স্যার
rules.
ফার্স্ট রুলে তো স্যার প্রপোজিশন লজিকের কোয়ান্টিফায়ারটা লাগানো যাবে না স্যার?
That is a different aspect. আমরা নলেজ রিপ্রেজেন্টেশনসকে কোয়ান্টিফায়ার ইউজ করেও করতে পারি, আমি রুল বেস টেকনিক ইউজ করে করতে পারি, আমরা সিম্যান্টিক নেট ইউজ করে করতে পারি। দ্যাট অল আর দ্য ডিফারেন্ট টেকনিক্স। বুঝতে পেরেছো? আমরা এইগুলো
Yes.
সব কিছু ইউজ করেই একই জিনিসকে ডিজাইন করতে পারি। সো দ্য থিং ইজ দ্যাট, সে there are some rule 8 that if the animal is a mammal and it choose card, then it is an ungulate and it is even to. And say there are also some say in some rule 11, if we can say that the animal is if we say the animal is an, it has long neck, long legs, tawny color and dark spots, then it may be that it is giraffe. So that type of rules you have to design. Now what will happen? There are two procedure. In your examination it may come that two important ways in which rules can be applied in a rule based system. One is known as forward chaining and one is called backward chaining. That means there are two ways that in which the rules can be applied. So there are two ways in which rules can be applied in a rule based system, and one is called forward chaining and another process is called backward chaining. So in forward chaining, what will happen? The known facts are used to deduce new facts. That means known facts are used to deduce new facts. Facts means it is always true. And in backward chaining, we hypothesize a conclusion. That means hypothesis a conclusion. We hypothesize a conclusion and use the antecedent consequent rules to work backwards. So how the forward chaining and the backward chaining will be applicable in that particular case when a robot that visits and zoo, and the robot should identify the different animals. So how it works, that we can see that, say, so how the forward chaining will be working like that. Forward chaining. So it may be the robot will just see the different features when he goes to the zoo. Say he finds some parameters that gives milks, and say then he have to apply, you just see the rule number 2, and he deduce that this is a mammal. So now what the robot actually sees, that we are applying the rule number 2, and then he sees that it choose card. So it say, then we know from the rule number 2 that it is a mammal, and if we apply rule number 8, then it will find that if the animal is mammal and it choose card, then we can apply the rule number 8, and rule number 8 we get that it is event toad and as well as angle. So now again the robot sees that the animal has long legs. It has the corresponding property that the robot detect, that it has long legs, say long neck, say in case of, you can say that tawny color and dark spots that the robot identify, and then he fired the rule. Already he find that event toad, ungulate and everything is there, and if it fires like that, this property is seen by the robot, and then he already determined that, then if we apply the rule number 11, then we can find that it will come out giraffe. So the animal, so actually these are the property that are seen by the robot, and there are some rules you are already been given. The robot will matching the if portions. If he sees the corresponding property, then the if portions matching if portions, it will fire the then portions, and then they are matching and they will find a particular animal. So that is called forward chaining. But in case of backward chaining, what does it mean? That in case of backward chaining, you will find that a particular assumptions or hypothesis has been made, and after that it will work backward. So there are several rules are there, rule 8, and if we just say some other rules like that, if we incorporate, say, rule number 5, that if animal is a mammal and it eats meat, then you can say it is carnivore. It is a carnivore. And say there is another rule you can define like that, rule 6, that rule 6 is like that, if the animal is mammal, it has pointed teeth, it has claws, eyes point forward. If this property is satisfied, then we can say it is ungulate. It is. So like that, if we take assumptions like in case of forward chaining, say this is a backward chaining, we are using backward chaining. So in case of backward chaining, say the animal is cheetah. If it is true, then we know, say some rules is there. If this is a cheetah, then it should be carnivore. It may be true. Tawny color, if we find true, and dark spot. And then if we fire some, we know for carnivora there are some rule 5, and we are matching like that. If it is a mammal, either it is true, either it is its meat or not, say false. Say that are the property, pointed teeth, that may be true, claws, that may be true, eyes pointed out, pointed forward. So that are the main thing is, in case of backward chaining, we take some assumptions and then we trying to match the property. So if the goal is to discuss all that can be deduced from a given set of facts, then do forward chaining. But if the purpose is to verify or deny one particular hypothesis, then do backward chaining. That is the thing. That means if the goal is to discuss all that can be deduced from a given set of facts, then you have to do forward chaining. And if the purpose is to verify or deny one particular hypothesis, then you should do backward chaining. So that is the case where the knowledge representations you are using some rule based system. So there are some other technique you can say, that is called knowledge representations using semantic nets. That is, you can say that knowledge representation, knowledge representation using, you can say, semantic nets. So this is the one of the technique. This is the first technique where we using rule based technique, and this is the another technique where we use semantic nets, and that is based on network structure. That is based on network structure. And কিছু বলবে?
স্যার
হ্যাঁ বলো।
স্যার ওই যে ফরওয়ার্ড চেনিং আর ব্যাকওয়ার্ড চেনিং ওই যে ডিফারেন্সটা মানে
হুম
ডিনাই আর ওইটা আরেকবার বলবেন?
হ্যাঁ ওটা বলছি যে if the goal is to discuss all that can be deduced from a given set of facts then do forward chaining. মানে we have a set of facts, মানে একটা রোবট একটা ঢুকে গেছে, আমি বিভিন্ন প্রপার্টিজ গুলো দেখছি, সেই প্রপার্টিজ গুলো দেখে I have to identify that which animal is there. Okay, then do forward chaining. But if the purpose is to verify or deny one particular hypothesis, মানে এটা চিতা কিনা, আমাকে যদি কোশ্চেন্স করা হয় যে যে এইটাই চিতা কিনা, তখন আমি কি করব যে হোয়াই, মানে why the animal is mammal, you have to prove that, then you have to do backward chain. That is the basic difference.
ঠিক আছে ঠিক আছে।
The thing is that it consists of points or objects. Points or object that is called nodes that are connected, by links. Links means is nothing but the relationship between two nodes. Okay, that are called, you can say, arc or edges. Now the thing is, nodes are usually that used to represent physical concept, objects or situations, and arcs that show the relationship between two nodes. And of course the relationships are of primary importance in semantic nets because they provide the basic structure for organizing the knowledge. So without relationship, knowledge is simply a collection of unrelated facts. So with relationship, the knowledge is nothing but a cohesive structures about which other knowledge can be inferred. So that is the thing. That means the nodes are, I am just giving an example like that. You can say that the Queen Mary is an ocean liner, and every ocean liner is a ship. If this comes like that, facts with no relationship. So if we can represent it by semantic net, that means this ship is an object, and we know ocean liner is a ship. So that means there is a relation that is called is a or a kind of. Like in your object oriented approach subjects, you will find there are different relationship, abstractions, specializations, or you can also find the relationship when you just reading the database where there is an entity relationship diagram. So here is one type of representations of a knowledge representation by using the name is semantic nets, and that is also like that Queen Mary is an ocean liner and every ocean liner is a ship. So we are just writing the ocean liner is a ship, and that Queen Mary, of course, Mary is also a ocean liner. So this is a kind of relationship. So that is nothing but, you can say, that semantic net representation. Semantic net representations. So we can infer Queen Mary is a ship even though the facts is not given. Even though we are inferring that Queen Mary is a ship by using this semantic net representation, even though the fact is not given. So actually this relationship that establish a property inheritance hierarchy in the net. This means that items that is lower in the net can inherit properties from the items higher in the net. That saves space, since information about similar node does not have to be repeated at each node. That is the property of inheritance, and instead it can be stored in central locations. So another important property of the net is a kind of relationship is transitive in nature. That is a transitive in nature. So the questions may comes that they will give you some this type of, and you have to draw the semantic net. They will can give you the options, or what kind of inference you can draw from this semantic net. That can be another questions that may be asked. Like that, if we draw another example of semantic net, it can be designed in different aspects, but একটা semantic net অনেক রকম অ্যাসপেক্টেই আঁকা যেতে পারে। সো আমাদের আগে কোশ্চেন্স আসতো এরকম, এখন তো তোমার চেঞ্জ করে দেবে প্যাটার্ন, যেহেতু এমসিকিউ। ধরো ইউ হ্যাভ টু ডিজাইন এ সিম্যান্টিক নেট। ধরো আমায় বলা হলো দ্যাট দ্যাট ম্যারি gave the green flowered vase to her favorite cousin. So you have to draw the semantic net for that particular sentence. So how can you draw it? You can draw it in different pattern, but like that you can say that Mary, and of course Mary is, you can say, is a person. So he gave, what he gave, the flower vase to this flower vase. Color is green, and that is favorite person, a favorite, you can say, cousin. That is also some person, and he received. That is the one of the procedure, not the that is the one of the procedure by which you can explain the semantic net. So like that, that means the main thing is that you have to represent the knowledge by using some nodes, and the relationship between the nodes should be expressed like that. So of course there are advantages, are easy to insert, but of course as well as it has some disadvantage, that lack of linked name standard. There is no linked name standard is given, that is difficult to understand by others. Inconsistent leveling, because আমি এইভাবে করেছি অন্যজন তো অন্যভাবেই করতে পারে, দ্যাট মিনস দেয়ার ইজ ইনকনসিস্টেন্সি লেভেলিং থাকবে, অ্যান্ড ডিফিকাল্ট টু আন্ডারস্ট্যান্ড, আমি যেভাবে করছি সেভাবে তোমার ভাবনা নাও যেতে পারে। So that's why there are some problems. Of course there are some disadvantage in the semantic nets, যেটা থাকবে। এবং যেটা লাস্ট আমরা বলেছিলাম, that is not too much important, but you should know the name, that a knowledge can also be represented by frame based, that you can say that frame based technique, that is a frame based technique. And in case of here frames are used to represent the knowledge, and of course the in a frame, we can say in a frame the parent of a particular object is given, and it will inherit the parent of a particular object. It will inherit the properties of the parent. So in a frame the values are given in the slot, এগুলো শুধু মনে রাখলেই হবে। in a frame the values are given in the slot, and it may be the questions comes out in a frame where the values are given. The values are given in slots because that questions comes in your WBT, that when the value of a particular property is not known, it is called a, you call a procedure, and procedures are nothing but is a rule. That means when it is required to insert a value, when it is required to delete a value, and when it is required to search a value. So it is nothing the case is that when the value of a particular property is not known, it will call a procedure. It will call a procedure. And procedure are of three types. The first type you can say if added, that means that when it is required to insert a value, that means when it is required to insert a value, then you call this particular procedure. Otherwise you have to call if removed, and of course the name suggests that when it is required to delete an object, and if needed, that means it is required to search a value. This is a search a value, that is a delete a value. So like that, this is nothing but the frame based knowledge representations. So the thing is that is the basic thing, that is you can represent the knowledge by using logic, you can represent the knowledge by using rule based system, you can represent the knowledge by using semantic nets, and you can represent the knowledge by frame based. That are the different techniques by which you can represent the same knowledge. That means that these are the representations technique. So today we just start about the searching algorithm that we discussed in the previous class. That so the thing is that there are several algorithms out there. That means mm, like that we already discussed the state based search. That means a search methods that are used to solve problem, that are searching a state space to find a path from a given initial state to final state, and the path found would indicate the steps required to solve the given problem. So that we already know, that is the chapter of state space search. So now the thing is that there are some searching algorithm. There are some searching algorithm. There are some informed search algorithm. There are some uninformed search algorithm. That means uninformed search strategy can find solutions to problem by systematically generating new states and testing them against the goal. But unfortunately, that uninformed search strategies are incredibly inefficient in most cases, because we know the thing is that is the search space. In AI, what is given, that particular node, say this is the initial state is given, and of course the goal state is also given. Now what will happen, you have to go from the initial state to goal state by using some algorithm, that is called the search algorithm. So there are different type of search. One is called uninformed, or you can say search algorithm, and there are some informed search. That means you can say you can add some heuristics in that particular algorithm. So uninformed means, that means not seeing the goal node, we are just expanding the nodes depending on my algorithm. আমার অ্যালগরিদমের উপর ভিত্তি করে আমি আমার মতো এক্সপ্যানশন করছি নোটসগুলো, বাট গোল নোডের দিকে না তাকিয়ে, মানে গোল নোডটা কোথায় আছে বা তার দিকে না তাকিয়ে যখন কোনো আমি অ্যালগরিদমের এক্সপ্যানশনটা করি, তখন তাকে বলা হয় আনইনফর্ম বা ব্লাইন্ড সার্চ অ্যালগরিদম। যেমন আমাদের আনইনফর্ম বা ব্লাইন্ড সার্চ অ্যালগরিদমের মধ্যে পড়ছে BFS, there are DFS, that type of algorithm are uninformed অথবা blind search algorithm হয়। whereas informed search মানে হচ্ছে যে আমাদের একটা পার্টিকুলার কি দিয়েছি, আমি একটা হিউরিস্টিক্স দিয়েছি। এবারে প্রশ্ন হচ্ছে, তাহলে আমরা যদি বলি যে হোয়াট ডু ইউ মিন বাই হিউরিস্টিক্স, মানে হিউরিস্টিক্স মানে তো আমায় জানতে হবে যে হিউরিস্টিক্স মানেটা অ্যাকচুয়ালি এখানে কি বোঝাচ্ছে, যেটা আমরা এখানে এক্সপ্লেন করব। সো হিউরিস্টিক্স আমরা যেটা বলতে পারি যে ডোমেন স্পেসিফিক নলেজ টু এস্টিমেট দ্য কোয়ালিটি অর পোটেনশিয়াল অফ এ পার্টিকুলার প্রবলেম। তার মানে হিউরিস্টিক্স মানে হচ্ছে, আমি ধরো আমি তো রেজাল্টটা সম্বন্ধে হয়তো জানি না যে আমি কিভাবে গেলে রেজাল্টটা পেতে পারি, আমি কি করছি একটা পার্টিকুলার ভ্যালুটা ধরছি। যেমন ধরো আমাদের এই হিউরিস্টিক্স বা হিউরিস্টিক্স কথাটার অর্থ দুটোর মধ্যে হতে পারে, যে একটাকে বলা হয় যে ডোমেন ডিপেন্ডেন্ট, মানে ডোমেনের উপর ডিপেন্ডেন্ট, অ্যান্ড একটা হচ্ছে ডোমেন ইনডিপেন্ডেন্ট। এটা হিউরিস্টিক্সের ভাগ। হিউরিস্টিক্স মানে হিউরিস্টিক্স ডোমেন ইনডিপেন্ডেন্ট। তাহলে ডোমেন ডিপেন্ডেন্ট মানে ইটস এ স্ট্যাটিক্স দ্যাট উই আর লুকিং দ্য কারেন্ট নোটস, অ্যান্ড ডোমেন ইন্ডিপেন্ডেন্ট মানে হচ্ছে we are modifying the original problem such that the solutions are easier to find than 24 puzzles problem or different types of puzzles problem, where is domain independent, where domain dependent means that it is static and it is dynamic. You can change the heuristic depending on the solutions of the problem. Now the thing is that, like that you can say that if this is the search space, if this is the start node and this is the goal node, then what will happen, it will, your algorithm will expand the node like that. Now in the next step, which node would be followed, it may be possible that you just calculating, say you know this is the coordinate of goal node, and say this is the x1 y1, this is the coordinate, this coordinate is x2 y2, that particular node has coordinate x3 y3, and you can find the Euclidean distance. You can find the Euclidean distance, and that is nothing but xg minus x1 whole square plus yg minus y1 whole square. Now if we find the Euclidean distance of all nodes with respect to goal node, and whose Euclidean distance is less, you just choose that particular node to expand next, then that type of this particular Euclidean distance in that particular case can be taken as a heuristics, or you can say that there is a Manhattan distance that also be taken as a heuristic. That means it can be used for solving the puzzles. That means, say this is the current position of this puzzle, say, so it may be possible, there are several ways. That means in the next step it may be possible that this is 2 4 8, it may be moved like that, 6 can be moved in the blank space, or there are possibility that 2 4 8 you can move 3 in that particular position. So there are several possible. Now the question is, in the next step what you have to, you know the goal node, because in that particular case you know the goal node. Gold node is like that 1, 2, 3, 4, 5, 6, and of course this is 7. So now we can find the Manhattan distance. From that Manhattan distance, that means number of blocks you need to change to reach the goal state. That means you can find in that particular case that 1, that means if we say this is one position you have to place, and 1 in that particular case at that position, that means at 1, 2, 3, at least you need 3 shifts if you want to place that 1 from that position. Now 2 in that particular position, you need at least 1 step to at that goal position. 3 is that particular position, so you need 1, 2, 3, or 4 step like that. If we calculate like that, that type of calculations is known as the Manhattan distance. That means if we write mathematically, the source minus and the ys minus 5. So this is nothing but, you can say, the Manhattan distance. So this is like that. That means number of misplaced type, number of misplaced types, that is the Manhattan distance. So you can say that is heuristics. That means when you just add that type of heuristics in a particular problem, that particular search is known as informed search algorithm, like that A star, AO stars, and all those stuffs are there. That is called the heuristics or informed search algorithm. So that is the basic difference. And as we know that you already know what do you mean by BFS and what do you mean by DFS, and what are the basic differences between that, I think you should know all those stuffs. So if I just share you a, say, you just, so the thing is that I think you should. That is the different search algorithm. So one of the search algorithm that we already know, that is depth first search. But here the algorithm is look differently. That you have to put the start node into open if we found false, while open is not empty or not found, remove the topmost n from open, and then it is placed. It is written in the different formats, but actually you know that in case of DFS what you have to use, and in case of BFS what you have to use, you already know that that BFS will take a vertex and start exploring it, and whenever first find unexplored vertex, we again go exploring and come back like that. So in that particular case, that means if we find an example, it would be clearer that you can say, so this is the corresponding graph which is given. This is S, this is M1, this is M2. So this is the open list, this is the closed list. First you have to just put the first node into S into open, and then in the next step you are just exploring the neighbors nodes, that is M1 and M2. We are writing M1 and M2 here, and then what node is already been visited, that is placed in closed, so it is placed in closed. And again you can select anyone depending on the architecture, that means M1 is inserted first or M2 is inserted first. Depending on that we are putting all the successor on the top of the open except those already in closed. Direct backward pointer to n from each successor. If ni is a goal node, then found equals to true, else if ni is dead, or remove it from open and clean up closed. So that is the procedure. So here you can find that M1 is taken out, and since m1 is taken out, it is put into closed, and we are drawing like that m1, and then from m1 we know there are two nodes, one is m3 and one is m4, and m3 and m4 are put it, and then we are just out from open is m3 and it will be placed in closed, and from m3 we know there are m4 and m5, and again m4 and m5 are put it into open, and you just m4 is taken out, and like that. So that you know that you have to find the corresponding path, that what should be the open. That means we are always giving a backward pointer to n from each successor. So that is nothing but the algorithm of DFS, and we know that what should be the algorithm of BFS. I am not discussing all those stuffs because I think you should know all those uh, thing is given, that is another algorithm, you can say that is the algorithm of BFS, that one is using the concept of queue and one is using the concept of stack. That is the basic difference, but the thing is that you know all those stuffs because you already been, it has been already discussed in your, you can say, in your data structures classes, algorithm classes. But the thing is that what we know here, we have to compare something that is completeness, optimality, and pace complexity and time complexity. So I think uh, uh, from the next onwards, we are discussing the algorithms and the performance measure. What we actually measure, that is completeness of BFS DFS, whether it is complete, optimality, and the space complexity and the time complexity. That four parameter you have to discuss with each of the algorithm, that whether BFS is complete, whether DFS is complete, whether they will give an optimal solution, what is the pace complexity and what is the time complexity. So there is some algorithm like a VFS, BFS, iterating, you can say. There are some algorithm that since this has some problem, so that's why there are depth limited search, there are iterative deepening, depth first search or DFID. That's four algorithm you should know, and then it will come to the